table, practice problem 4. Problem 4 reads, on 5 March 1983 at 0630 EST ZD plus 5, what will be the predicted height of tide at Ocracoke Inlet, North Carolina? All right, we can figure that one out. So 5th of March, now what? At 0630, so 0630 EST ZD plus 5, good. What will be the predicted height, right? What's the height at Ocracoke, cool, Inlet NC. So the 5th of March at 6:30, what is the height of tide at Ocracoke Inlet? Let's set this problem up. There's a few things we know we're going to have. We're going to need a reference station. What's that? And then we're going to go to table 2 and we're going to get our differences. So we're going to get differences for the time of the high and the time of the low. We're going to get differences for the height of the high and of the low. Now that we're set up here, we can go into our index, find Ocracoke Inlet. So it's under O, L, M, N, O. Here's O, O, A, L, O, C, O, C, R, Ocracoke, and C. No, here's one. Ocracoke Inlet and C. 2458. 2458. Okay, now we know what we're looking for in table 2. 28, 26, 2433. Good, I think we're onto something here. 2458, 243, 2458. There we are. Now let's get our reference station. So we follow right up the middle. Hampton Roads, page 88. Hampton Roads, page 88. And now here's our differences. Again, difference time high, difference time low. Difference height high, difference height low. These are the 4 columns across. We set it up the same way. So our time is minus 138, minus 138, and minus 141, minus 141, and the height is minus 0.6 and 0. Okay, good. So we head into our table 1 on page 88. Here's the page numbers. Jumps around a little. There's 88. And we are looking for 5th of March. Okay, so it's right up here. March 1, 2, 3, 4, 5. March 5. Okay, so it's 6:30 standard time. And now 6:30, where does that fall? Here's a 139 and an 8. You know what's interesting though? You see this 8 and this 13 right here. What happens is we have to consider the time correction. So 8 a.m. is a low. If we subtract an hour and 41 minutes from 8 a.m., it's down to like 6:20. So it's going to be between 8 and 13:58 when we consider the time correction. So let's record these. Right here we have 800 is 0.2. So 0800 is 0.2. And 1358 is 2.0. Okay, now we can crunch some numbers. Now, 800's a low tide at 0.2. Here's the height correction. Okay, good. And now let's do the height correction for the high, 2.0. 2.0. And we are going to be 0.6 feet less than 2.0. So we're going to be 1.4. Let's find our range. The range of the tide, which we'll need for table 3, is going to be 1.4 minus 0.2. What's our range? It's going to be 4 minus 2 is 2. 1 minus 0 is 1. Our range is going to be 1.2 feet. Now let's get our times. So the time of the low is 800. The time of the high is 1358. So I'm going to have to reset this up because I can't do all this in my head, and it needs to be set up properly. And I also have to give myself room to borrow and everything. Time, don't take adding and subtracting time for granted. It gets a little tricky. So 1358 minus 138. What's that equal? And the other problem is going to be 0800 minus 141. Okay, 8 minus 8 is 0. 5 minus 3, 5, 4, 3, 2. Now 3 minus 1 is 2, 1 minus 0, so 1220. 0 minus 1, we got to borrow here. Good thing we set ourselves up properly, huh? And now there's a 7 here. And so this would be 60, but we'd still have 0 minus 1, so we have to borrow. So this turns into 50. We borrow 10, right? So 10 minus 1 is 9. 5 minus 4 is 1. 7 minus 1 is 6. Good. So here's the times of the high and low. And now we need to figure out the duration of this tide. Duration equals, so take the big one minus the little one, 1220 minus 619. Oh, nice. We can take 19 from 20, but we're going to have to borrow to a 10. 10 minus 9 is 1. 1 minus 1 is 0. And wow, this 1, 0. That makes this to a 12 minus 6 is 6. 601 is the duration. Now we need to figure out our last piece so we can enter table 3, which is time. The time from nearest. So is this 6:30? Is it closer? Oh yeah, this is the obvious one. It's closest to 6:19. So we go 6:30 minus 6:19. So it's a low. Time from nearest, low. And we are going to say 6:30 minus 6:19. What does that equal? So borrow from here, it's a 2. That makes this a 10. 10 minus 9 is 1. 2 minus 1 is 1. 11 minutes. Now we have our range, duration, time from nearest tide, which is this is low. Now we can enter into table 3. And get a difference at any time. So again, table 3, I always bend my corner here. 239. And we are going to enter in on table 3 from duration of rise and fall. What's our duration? 601. 6. Good. 6 is the choice here. And now we come in from the top, time from nearest high water. So we cruise around, and we're only 11 minutes. So right, the first one is 12. Boom, we're right down here. And now we come in from the side, range of tide. The range of tide is 1.2. So 1 point, looks like we have 1.3. So our correction is going to be 0. Well, that's easy. And because we're using low, this would be added, right? So you take the low, 0.2, 0.2, and you add 0.0. So it comes as 0.2 is the height of the tide, 5th of March at 6:30 at Ocracoke Inlet, North Carolina. Let's check. This is problem 4. Yeah, look, we have A is 0.2. Nothing else is really close. So 4 is A. 4 is A. Looks like we solved this one. Keep going with these. We're going to solve one more together, and then there's 2 to do on your own. And we'll have an overview that breaks this down as well. Keep going through these. Don't get discouraged. We are good to go. I'll see you on problem 5.